Hello IB students, I'll be solving question 5 from the Physics HL paper 2 2024. Let's get started. A 50 ohm resistor is connected to a cell of EMF 3.00 volts. The voltmeter and the ammeter in the circuit are ideal. The current in the ammeter is 59.0 milliamps. We are supposed to find the internal resistance of the cell. So the cell is not ideal, it has some internal resistance. Let's model that by this resistor R. Well, we know the current is given to us. The current is 59.0 into 10 to the minus 3 ampere, and the EMF is given to us. The EMF is 3.00 volts. We can quickly find the total resistance of the circuit. The total resistance is the EMF divided by the current. The EMF we can substitute 3.00 volts, and for the current we have 59.0 into 10 to the minus 3 amps. So this turns out to be about 50.847 ohms. Mind you, this is the total resistance of the circuit, 50.847 ohms. The total resistance comprises due to two resistors, 50 ohms and this R. The internal resistance therefore is the total resistance, which is 50.847 minus the resistance of this resistor, which is 50.0 ohms, which turns to be about 0.847 ohms. This is the internal resistance of the cell. Alright, let's move on to the next part. The circuit is changed by connecting another resistor R in parallel to the 50 ohm resistor. That's shown here. Explain the effect of this change on the reading of the ammeter. We must realize that whenever we combine two resistors in parallel, as we have in this case, these two resistors are in parallel, the total resistance of the system is always smaller, meaning the resistance of this combination here, of this entire thing, is going to be less than both of them, 50 and R. And what's going to happen due to that? Well, if the resistance is small, the current is going to be larger. So the current increases. The reading of the ammeter is going to increase due to the decrease in the resistance. Let's look at the next part of the problem. What's the effect on the reading of the voltmeter? The voltmeter measures voltage between these 2 points. In other words, the voltmeter measures the terminal voltage, V terminal. And we have an equation for the terminal voltage. The terminal voltage is equal to EMF minus the current times the internal resistance R. Now, if the current increases, the terminal voltage will decrease. If there is a decrease in the terminal voltage, the voltmeter is going to measure a smaller reading. And that solves this part of the problem. Let's push on to the third section. R is made up of a resistive wire of uniform cross-sectional area, 3.1 into 10 to the minus 8 meter square. Resistivity is given to us and its length is L. The equation of resistance is R equals KL, where K is a constant. Calculate K and give the appropriate units for our answer. We already know the equation of resistance. Resistance is equal to resistivity length over area, and this has to equal K times L. That's given to us. So equating this to KL, L and L goes away, and we can have the equation for K. K equals resistivity over area. Resistivity is given to us and the length is given to us as well. So we'll just plug those values into the equation here. Doing that leads us to 4.9 into 10 to the minus 7 ohm meter divided by 3.1 times 10 to the minus 8 meter square. Alright, so if we solve this, plug this into a calculator, we get a value of 1.58 into 10 ohm over meter. That is 15.8 ohm meter. Since the input data has only two significant digits, 4.9, that's just 2, we will approximate this to two significant figures. That's 16 ohm per meter. Okay, that solves this part of the problem. I hope you found this video helpful. Make sure to check my other videos. If you need more help, feel free to reach out. I teach one-on-one and I'll be happy to help. Happy learning.